So what does it mean when ln of something is negative? And what does it mean when ln of something is positive? Because we have so many equations, I want to just do a quick overview. Some of the equations we have ln of q, right? So ln of q is ln of product with reactant. Now what happens when ln is 0.5 versus when ln equals 5, right? And so when you put in a calculator, anytime I have a fraction, I always get a negative number. Whenever I get I always get a positive number when ln is greater than 1. And what I want to show you relationship to here is this. If ln of q is negative, that means I have more reactant than product. And if you don't believe me, plug in a calculator. Remember I said ln of q equals product with reactant. And so let's just say I have a lot more reactant, then I should have maybe 10 product and 20 reactant. And from that I get 0.5. And so ln, whenever I have a fraction, that means I have more reactant, which means I get a negative ln number. Likewise, when I have ln of positive number, what that means is I have more product than reactant. Okay? And I also mentioned log here because ln and log is the same thing, just telling you the two different things. But it's a quick preview. I am also going to mention about log of base over acid, which is a buffer problem, but the same rules apply. Okay? So just a quick recap. If ln of q is positive, does that mean I have more product or reactant? Right? So if I were you, remember q equals product or reactant, put it in a calculator. 10 over 2 versus 2 over 10, right? And if you put this in a calculator, this should be the positive number, and this 2 over 5.2, this should be a negative number. And so this is, guys, very important. If an ln of something is positive number, that means I have more product than reactant. And if I have ln of something is negative, I have more reactant than product. So let's do a couple practice. First, just for now, we have a couple equations that we use ln or log. And let's start with the first one right here. This is from Gibbs energy, okay? And here's a scenario. You are given delta G naught, and you realize delta G is negative. So from this, did I add more product or more reactant? Okay, and let's break it down. So I have a positive number and I ended up with a negative number. So that means I added a negative number. And so what is a negative ln q? Does that mean I added more product or more reactant? More reactant, right? And if you're not sure, please do the math again. But the big picture is this. From this equation, I needed a more negative number, right? So that means for this Gibbs energy, for it to be spontaneous, I had to add more reactant. Now let's focus on this equation right here. This is a Nernst equation. And so here is I'm given plus 5 and I ended up at a positive number. So what that means is I need a positive I need a positive value here. Okay? But what's very interesting is here is I already have a negative sign. So I need my ln of Ken to be also negative. Why? Because negative times negative is positive. And so if I want a negative ln value, right, do I need more product or reactant? And so hopefully you said it's a reactant. Okay? And then let's do a last problem for buffer. Let's just say I'm given a pKa and my final pH is 7. Did the number go up or down? It went up, right? It would become more positive. And so for this log, right, do I need more base or more acid? Hopefully you said it was more base, right? Because a positive log number means I have more product than reactant.